So let's take a look at that class assignment. I do want you to follow along with me today, and then you'll have an example, like I said, for your homework. Okay. And in this programming problem, we are going to convert from kilograms to pounds and pounds to kilograms. And we're going to write a program that displays the following two tables side by side. And so it says kilograms, pounds, and so we have our kilograms from 1 to 199. And then we have our pounds from 2.2 to 437.8. So it's those 1 kilogram equals 2.2 pounds. Do you see how that converts? And then on the other side, the second table that's next to it starts out with 20 pounds and goes to 515 pounds. You can see it's going up by 5. Okay. And then the kilograms, you know, this is our converted 20 pounds to 9.09 kilograms. Okay, so same kind of conversion factor there. So we just divide by 2.2, right, to get our kilograms. Here we multiply by 2.2 to get our pounds, and here we divide by 2.2 to get our kilograms. Now you can kind of see, maybe if you've programmed a lot, that, hey, this is great for a loop, and it is. It's from a looping chapter. We are going to use a loop to solve this problem. And when you see a problem like this, and it has repeated values, repeated output, you should think in your head, hopefully, loop. And then as you get more advanced and know more about programming, you should think function. Now, we haven't gotten to functions yet, so we're not going to write a function here. But, you know, as you get better at programming, you should think, this would be great for a function. This would be great for a loop. Now, I can see where to put that loop in here. I'm going to put a loop to output every row. So every row. So I only need to concentrate on outputting one row in my loop and then loop it a certain number of times, and I can output all of my rows. Okay. Now you guys tell me, if I start out at 20 and I count by 5s and I go to 515, how many rows are there? Notice they don't show me on my rows. They put a dot, dot, dot here. But how many rows are there? How would you figure that out? How many rows? That means how many loops are we going to have? So it's how many rows? Huh? 200, someone said? Okay, so notice that we're going from 20 to 515, and we're counting by 5s. So one easy way to kind of figure that out, actually, is to take 515 and subtract 20, and then divide by 5. And then add 1, and why do we have to add 1? Because we're including, we're doing it inclusive. So it's actually 100 rows that we want to print out. Okay, so we're going to have 100 rows in our output. Okay, and if we get the wrong amount, you just change the number, and it's really easy. So, but we need about 100 rows to output all these rows. Okay, so we can kind of think that, hey, we're going to loop 100 times. Okay, so our loop is going to count for 100. All right. So let's start this thing. All right, and I do want you guys to follow along today, and we'll go slow. Okay, but then you'll have this nice example to use for your homework too. Okay. All right. So I'm going to help you program this first table, and then I'll help you program this part, and then we'll see if you guys can get the last column by yourself too. Okay. All right. So let's go to File, New, and we'll make a new source file. Sorry, she was eating the electricity. We had to stop that. We don't want a dead dog. Okay, sorry. We'll cut that out of the video. All right. So remember to put your name at the top. Okay, hopefully you've been doing this. Okay, you always put your name at the top. I don't grade down on your first programming problems, but after a while, okay, make it your habit. And then it's always good to put the date and then which programming problem is. This will be our conversion problem. And it is pounds to kilograms. Like kilograms to pounds and pounds to kilograms. All right, hopefully you've gotten used to and better at starting your programs by reopening a recent program. And then you can copy and paste the beginning of that program because it always stays the same. Unless you like typing it. There's always benefits in typing it, but the beginning of our programs in this class 99% of the time look like that. So if we get good at copying and pasting them, that's cool. Okay? All right. And this is review week, so maybe we should review kind of what this does. You guys remember what your pound include IOStream does? Yeah, it calls that library so we can use cout and cin. So that's how the program knows what cout means and it knows what cin means. Okay, it incorporates that library when it compiles. It links it when in the compilation process. Okay. And then the using namespace standard tells us that we're using the standard library out of here. And we write this to make our coding a little bit easier. When we look online, you might see some weird std : and then cout. Have you seen programs like that online? Okay. And it's because they left that global namespace out. But to make our programs easier, that's why we write that there. It just makes it easier to write for us. And then we all know what int main is. Int main is a function, and it's the function that runs when we execute our code. Okay, but it is called a function. We know it's a function because it has the parentheses. Whenever you see parentheses after something, think function. Okay? If it doesn't have parentheses, think variable. All right. So let's start this thing. So we can think about some variables that we need for our program. What kind of variables do you think we'll need here? Maybe one for kilograms, one for pounds. Okay, that would make sense. Remember that you don't have to remember all of your variables when you first declare them. You can make them as you go. Okay, so I know I'm going to need a pounds variable. And I know I'm going to need a kilograms variable. And I made them type double. Now looking at this programming problem, I can see my kilograms are whole integers here. But over here, they're decimals. And then right here, I have pounds that are decimal, and then pounds that are an integer. And since we have to print these rows out together, this might seem a little odd, but I think it makes sense to make an integer called kilograms for this column, and then use the double kilograms for this column. Does that make sense? And then use the integer pounds for this column and use the double pounds for this column. Okay, so I'm going to make another variable, and I'm going to make him type int. Now he can't have the same name. I can't name him pounds, but I can name him pounds int and kilograms int if I want. Now remember, there's lots of ways you could program this, and you don't have to program it this way. I think it just makes it easier to have 4 variables for the 4 variables we're printing out, so we can keep them separate. Okay, so that way they don't get mixed up and mess up each other and things. Okay. Now for my pounds int, where does he start at? He starts with the value 20. So it makes sense that I would initialize him to 20. Okay. So I'm going to initialize. Remember that this is called your declaration when we're declaring the variable. And then this is called your initialization. So those are 2 key words you'll see on the test, so remember those. Declaration is when we tell the computer what kind of variable it is and how much RAM to set aside. And initialization puts a value in that RAM location. Remember? And then our kilograms int starts out at 1. So we'll just put him as 1. We'll initialize him to 1. And like I said, if you guys want to, You know, I know a lot of people have programmed in the past and they're really good at programming. You could program this differently if you want to. I always, you know, programming is a very creative process, and you know, there's lots of ways you can program this. So if you want to branch out and you think you can do this on your own, then I say go for it, right? Okay? And we can see all the different ways that we could program this. So I'm just showing you one way. And then I could post other people's ways, and you can see the different ways you could program something. All right. Now, first things first, we need to print this header for our table. Notice that the header, kilograms, pounds, line, pounds, kilograms, only happens one time. He's not repeated, right? So I want that outside of my loop. It makes sense that that's outside of my loop because it only appears once. Okay. So we are just going to print this to the console output. So I'll just use a cout statement. And I'll just cout my kilograms, pounds, line, pounds, kilograms. And I can use a tab character to help me out. So I'm going to write kilograms, and then I'll want to tab over. Do you guys remember the tab character? It's actually /t is our tab, and that'll tab us over or skip 4 spaces for us on our output. And then we can have our pounds, and then I'm going to tab over again. And then I'm going to have that line, and it's just the OR line. It's the up and down line. Now, I didn't leave a space in front of my, I'll put a space here so you can see the tab, but you don't necessarily need that space. Okay. So then we have tab, and then we have that line. And then I'll have a tab, and I'll say pounds. And then I'll have a tab, and I'll say kilograms. Now, there's no, you know, perfect way to make this output. I always say just try something, and if it looks right, leave it, and if it looks wrong, fix it. Okay, so we can try this out. Notice it only outputs this one line, but just to see how this outputs, remember you can compile him. And I'm going to call him conversion.cpp, but you can call him whatever you want. Just to see how that tab works and that we printed it out right, and there he is. That looks pretty okay. He's a little bit more spread out than what they had in the text, but that's okay. As long as we use tabs in our output for our numbers, he'll still look fine. All right, so everybody saw how the tab works? Hey, speaking of, this is our review week. Do you guys remember the other escape characters? These are called escape characters. Another fun one is the /a. Do you guys remember what /a does? In order to see what /a does, you do have to have the sound on. Oh, did I turn the sound off? But it makes a beepy sound. It's an alarm. In fact, if you want a really annoying program, put this inside of a loop that loops a million times. That would be really annoying. Just output that 1 million times in a loop, right? I thought about doing that in here, you know, when we're doing loops, but you know, I never actually made that an assignment yet. All right. Because this is review week, so we're kind of reviewing, right? But those are called our escape characters. And in your book, he has a few of them. But tab's the one that we use the most. All right. Oh, yeah. Okay. So now we need to make our loop. Now we can make a while loop or a for loop. Remember, every time you make a for loop, you can convert it to a while loop. And every time you make a while loop, you can convert it to a for loop. Okay. Now we know exactly how many times we want, how many rows we need. So what loop should we make? Should we make a while loop or a for loop? Now my brain says for loop because I know exactly how many times I want to execute this. But you could do a while loop just as easy. Okay. In fact, because today's review week, we'll probably finish this early. We can convert it to a while loop after to see how it converts to a while loop. Okay. But when you know exactly how many times you're going to go, most programmers will opt for a for loop because you know how many times you want to loop. And a for loop is nice and neat, and a lot of programmers like for loops because all of your loop control is inside of that header for your for loop. Okay? So let's try out a for loop. I'm just going to make it a simple for loop that'll loop 100 times. Note that by looking at this for loop, I can tell that he's going to loop 100 times. When you're looking at the heading of a for loop, if it's a well-written for loop, you should know how many times that loop is going to iterate. Remember, iterate means how many times it's going to loop or execute. And it's going to go from 0 to less than 100. So how many times it's going to loop? 100 times, right? Okay. So that's how you make a loop 100 times. All right. Now I just want to make one row. And the reason I want to make one row is when I loop 100 times, it'll make 100 rows for me. But I just need to think about how to make one row. And then when it loops, it'll automatically make it 100 rows. Okay? So I was going to think about this row right here. So we have kilograms. And then we have pounds. Then we have pounds, and then we have kilograms. So what do we need to output right there? Our kilograms integer. That's why we made this variable. We started him out at 1. We can just get him to work at first. Notice he goes from 1 to 3. Okay, he goes up by 3 each row. But let's just worry about printing him out at first. So we can see out our kilograms integer. And then we'll tab over. Note that when we tab, we're going to concatenate that integer with a string. And inside of the string is our tab character. Okay, so that'll glue that tab character and make it tab over. Okay. Should we do one more output? And then we want it to be pounds. And how do we calculate pounds from our kilograms integer? Yeah, we would just multiply the amount of kilograms times 2.2, and that would give us our pounds. So I would just take that kilograms integer, multiply it by 2.2, and now we have our pounds. Now always double check yourself. Hey, am I doing int math? We have an integer times a double, and what does that give us? A double, so we're okay. Always check your math that you're not doing int math. All right, let's print out that and just see how it looks. So remember, you just code something and then you test it just to see how it looks, to see what we need to change in here. Now he does. Oh, you know what I forgot is my endl. I forgot my endl, so he just tabbed over and just kept printing him. So here's my end line character. You need to put the endl in there. Now we're going to get rid of endl in a second because you can see that we want it to be a cross. But just for now, you can put the end line character so he will skip a line. Okay. So when we run this thing, we can see that the first row looks great. Well, the first row for kilograms and pounds almost looks great. But then the subsequent rows do not look correct. But that's okay. You program it like this, and then you say, hey, what do I need to change here? I need another tab character, obviously. So I need to tab over again. Okay. Or do less tab up here to get them in the right column. And then what else do I need to change? Yeah, I need to increment that 1. Notice he just stayed 1 the whole time because I didn't change the value of kilograms int. So I need to change the value of kilograms int in my loop so that the next time around when he loops, he's a different value. Okay? So let's put those changes in here. If I want another tab character, I would just put another /t. And then I need to change kilograms int after I output him. And how do I need to change him? I need to add 2 to him. So notice he's up by 2 each time. Do you see how I went from 1 to 3, and I go 197 to 199? I'm adding 2 each loop. Okay. So here's where you can do your plus equal operator. And remember, this is our review week, so we should remember what this means. It means that it equals kilograms plus 2. So remember that this line of code is the same as this line of code, but we write it this way because this makes us look smarter. Really, it does. One is less typing, too. That's why programmers do it. Plus, it makes you look like a programmer because then you're using that shorter syntax. Okay? And you guys are all programmers now. You know that, right? Yeah, you've made it this far in the class, you are a programmer. All right. All right, let's print it out again. So you run it again and you see what he looks like. Okay, yay. The kilograms looks okay. It is upping. The pounds look okay. Our formatting needs a little help, but we'll worry about formatting after. Okay. Or we can, but we can make sure that we're getting the right answers here. So we have 2.2 and 6.6 for 3. And then at the bottom, 197 is 433.4 and 437.8. And we can double check in here, and yes, those look great. All right, so we got the first 2 columns down. All right. How do we make the next column? The same way, really. Okay. So we're going to see out for our next column. I guess we can change this in a second, but we'll see out for our next column. And in our next column, we have pounds starting out at 20. Okay. Increasing by 5, and then we have our kilograms, conversion of that 20. So where did I have my pounds integer? I named him pounds integer, and I started him out, or initialized him to 20. So he could be the next output. Notice it kind of looks the same as up there. Doing the same thing. I could tab over twice again. And if it's too many tabs, I would take it away after. See how we're making this thing? And then my pounds integer. How do I convert pounds to kilograms? Convert kilograms to pound. Oh wait, no, that was pounds to kilograms. Can someone get the door actually? So last time we converted our kilograms to our pounds, now we'll convert our pounds to our kilograms. So we're just doing the opposite. So how do I convert that guy? Hopefully you know. Yeah, you divide by 2.2. You just do the opposite. Okay, to go from 1, you multiply by 2.2. To go back, you just divide by 2.2. And hopefully that makes sense to you guys. Okay. And then I'm going to put my endl right there. See how we're kind of building our table? Now I know I'm going to get the wrong output, but you guys can check your output as well. And the reason I'm going to get the wrong output, well, I don't want to tell you. Let's see if you can figure out why we got the wrong output. What did it do wrong? It put the 20 down here and its conversion next to it, and it should be up here. So what did we do wrong? Right, it's that end-L right here. When we put the end-L, we put it preemptively. We don't want to hit enter. Remember, the end-L is like you're hitting enter and going to the next line. Okay. So what we need to do is just get rid of that end-L and replace it with a tab character. Because we want a tab, we don't want to just go to the next line. You know, we don't want to go to the next line, we just want to tab over. So I replaced my end-L, or my end-of-line character, with a tab character. And we can see what it looks like. So remember, you kind of build it in parts like this. Okay. He's looking better. What should I do? I should probably add another tab in here. And that line. I should probably add that line and then another tab. Or another tab and then line. Okay. So we can fix that up. I'm going to add another tab. And that up and down line, which is just our OR line. That's our OR operator, remember? And just try to get it lined up right. So that looks pretty okay, but I need a tab after that OR line maybe. You see how you kind of look at the output and then you say, hey, I need another tab right after that line. If I hit tab right there, he'll line up a little bit better. So I just go to where my line got output and say, oh, I need another tab right after that line. You see, you kind of look at the output, yeah, we messed up, and then you try to fix it. For some reason, a lot of students find this hard, but you just, you know, there's no perfect way. You'll probably not get it right the first time. Okay. Then you line it up and you say, oh, that looks a little bit nicer. I'm still a little bit off. Now the reason I'm a little bit off is because I skipped a line up top. Do you remember when I skipped a line to show you guys how it'd be a little bit clearer? So if you get rid of those skipped lines, he'll actually line up quite nicely. You see how I got rid of my little white space in there? So then, oh, I forgot to get rid of my white space in front of the line. But see how they kind of line up better? Now for your homework, I'm not going to be super nitpicky that they're lined up extremely. But you should get it mostly fixed up. Okay. And remember, you can make your output look even better than their output. All right, so we're getting somewhere. This looks pretty nice. But what do I have for my pounds here? I'm getting the wrong output. My pounds need to increase by 5. So I'll do the same kind of methodology that I did up here, where I added 2 to kilograms. Now I want to take my pounds integer and increase him by 5. Okay. So that way on every loop, now make sure you do the order of operations correctly. You output them and then you increase by 5. So now he looks much better. All right. And actually, did we get the right output? So our last output was 234.09. You should check that you got the right output. And there it is. Now the only thing left is to properly format these. So note that he is 1 decimal place and this guy over here is 2 decimal places. Okay. Yeah, so we're going to have to use our floating point set precision. right, so let's do how they did in this example here. We'll use the set precision like how they used. And we've done this before. We can use this library, and then we set our precision before we output that variable. Okay. So what I'm going to do is I'm going to include this library. And the library that they have us include is the IO manip library. So IO input output manipulation, that stands for. So we're just including another library so that we can use that set precision function. I know it's a function because it has parentheses. Okay. And we use that set precision function right in our cout. So when we're outputting this thing, that might be a little bit longer of an output. Remember that you could split up your output like this. Now I'm going to split up mine. You don't have to split up yours, but I'm going to split up mine so that you guys can see what I'm writing here. Okay. So this guy that I want to be 1 decimal place. So I'm going to use that set precision function right here and tell it to put a precision of 1. Okay, same thing here. I'm going to skip a line, and you guys don't have to skip a line, but I skipped a line because I ran out of space. And I can do my set precision for 2 decimal places for my pounds integer. Because in our table, I think that's what kind of made that programming problem a little bit harder, right? Is that one had 1 decimal place and then one had 2 decimal places. In your homework, I think it just all has the same amount of decimals. Oh, and it put it in scientific notation. Damn it. I think we have to tell it to... Which one?
It says whether you could set it as scientific or fixed or scientific.
Yeah, we need fixed. There it is. In both the fixed and scientific notation, the precision field specifies exactly how many digits to display.
It's right there where it says format flag or float field. Right there with the loop in parentheses. Yeah.
All right. So we could look at this one right here. And we could just tell it fixed. All right. So I'm going to tell it fixed and fixed. Yay, and now he's all fixed. So putting fix fixes him. Just kidding. Now, just so you know too, this is a little bit more knowledge than probably you need to know, but doubles are stored in scientific notation in your computer. So that's why it always defaults to the scientific notation. Okay, so in your computer, your double number is always reduced, or not reduced, but changed into its scientific notation, and then the exponent that it reduced it to is saved in one part, and then the decimal part is saved in one part. And that's how double or floating point numbers are saved in your computer. So that's why when we print it out, its default is that scientific notation. Okay? But if we put that fixed in there, it tells it to fix the decimal place. And actually, we only need to put it once, but we can put it twice if we want to. Okay? All right. And voila, we have a beautiful table, or 2 tables next to each other. And it looks very much like our output. Okay, cool. Not too hard, right? All right. I knew this one would be a little bit shorter today to finish. Oh, and I was going to have you guys make the the other column, but I forgot. We gotta make it together. All right. So you guys are going to turn this in. Don't turn it in until it's actually working. So make sure that it works. I'll come around and help you if you need another pair of eyes to help debug. But you will turn it into your class assignment here for class points. And actually, we're done like hecka early. So what we could do right now, actually, if you guys had other questions on your homework or labs, we could go over those. We could spend this time going over them. Okay. In fact, we can look at our homework this week. I haven't graded it, but anyone want to volunteer theirs? Their program for homework and lab for our loops? We could see different ways that people program this. So hopefully everybody got their homework in. When did I make this? This was already due, right? Oh, I made it due tomorrow for some reason. Maybe we'll wait on going over that one then. We could go over this one. This one's already due. We can go over the other one on Thursday after it's due. That way I'm not like, if anyone hadn't turned it in yet. It was probably supposed to be due today, but yeah, I put it Wednesday, so we'll keep it Wednesday. You guys, yeah. But we could look at this programming problem right here as a good review. Anyone want to volunteer theirs? Jeff? Okay. And this was lab and homework on our strings. Mm-hmm. A lot of times when I'm grading these, I'll have them open like that and then just copy and paste them into a program. That's how I usually grade. It's usually the fastest way to grade these things is you open them, and just for you guys too, just for your knowledge how to run these things, you can open it in Notepad++, copy and paste it into a program that you have saved, and then it's pretty fast. Okay. Mostly because of Java. In Java, you have to have a project and everything, but all right. So remember this programming problem, what it looked like. It was the one to calculate your BMR, and it was our branching problem. Okay. You're supposed to calculate the BMR for a male or a female, and then calculate how many chocolate bars they can consume to maintain your weight if you just wanted to eat chocolate bars. All right. So right away, it looks pretty great. He got his name up there. Everything looks cool. Now, the only critique I would say about your variables is that this variable should be lowercase. Now, it doesn't make your program break that it's uppercase, but uppercase variable names like this, when they're all caps, are usually reserved for constant variables, variables that won't change. And maybe that was kind of the trick in this problem. I don't know. Every book up here has a programming problem where it has a cap, and then you're supposed to make it lowercase. Something like state names or person names or BMR is capitalized in our world, but in a program, you would still lowercase it. Okay? So, Dun, dun, dun. Where is he? Oh, there he is. So I would probably say, hey, since we're critiquing it and we're going over and reviewing things, stick to lowercase variable names unless you do want a constant variable, and then you could have all caps. And we haven't gotten to arrays yet, so we haven't really made that many constants. Actually, I don't think we've ever made a constant in here. Okay, so I wouldn't grade you off for that one, but you should know. Okay, hey, lowercase. And so he declared his variables. He didn't initialize any of them, but then he does that initialization process in his input. Okay, so this looks like great input. And notice how he kind of spaced it out. He has his declarations as one block, with no white space or new lines. And then he has his input as one. And then he has his do while and then his else ifs. Okay. Well, anyways, his input looks pretty nice. Getting the weight, the height, and the age. Okay. And then Jeff does like to use things like this, which is a little bit, out of the scope of this class, but we can look at what the start does right there. That's why we like looking at these programs, to learn from each other. So he does have a do while loop, and remember this is our review week, so do always at the front with no semicolon, and then while is the only Boolean or only loop or branch or whatever that'll have a semicolon at the end. Okay, so remember the do while has a semicolon at the end. Okay, and he writes, are you male or female? And they're supposed to type in M or F. And actually, this is a great error checking loop. Now, if you didn't put this loop in here to error check, that's okay, actually. I didn't say that you had to do error checking, but it is good programming practice to start to error check these things. When we start error checking, it does add a lot more code to our programs, but it makes it so our programs won't break, okay, when we do error checking. Okay, but you didn't have to do the error checking. I didn't say, hey, do error checking. But this is great to look at this. So he has a do while loop, and he keeps the user here in the do while loop until when? Until they actually type in an M or an F. If they don't type in M or F, if the gender is not M or F, it keeps them here and keeps asking them, are you male, are you female? Until they type in an M or an F, it'll stay here. Now he has this branching statement here. Actually, let's tab it in here. Now you can write them like this, and you'll see code written online like this. But it is customary in our class to go to the next line and indent after our if. And he's saying, hey, if the gender, what they typed in, this gender character, is not an M and is not an F, he skips a line and then yells at them, please enter, well, not yells at them, asks them nicely, please enter a valid gender. So that's his little error message. Okay. And note why he had to have that branch in there. So if they do finally put an M or an F in here, he doesn't want to tell them to do that again. So he had to have that branch to check to see if he had to output this error message. Does everyone kind of see how that do while loop's working? It's good to look at code like this. All right. Now he does put spaces in between the if and else if, and that looks all nice and neat. But just so you know, a lot of people will not put spaces in between those because they want to show that they're together, and they will take the space out. A lot of people will. And a lot of programmers will actually even put this else if near that ending curly bracket. It doesn't mean that you have to, and people have their own styles and things, okay? But just note that it does show that they're related when you kind of don't put that space in there. And spacing doesn't ruin your program. It still compiles the same, but it just makes it for readability and for standards. Okay. All right, and then he used the equal equals operator because he used characters, and that was fine. Okay. And note, because he error checked over here, they had to type in a capital M and a capital F, and so he didn't check for that lowercase f. I noticed a lot of people on their programs, they actually did check for the lowercase f. Okay, but he didn't have to because he made them stay here until they typed in a capital. Because remember that capital F is different than lowercase f. All right, and then he does his calculation, and his calculation looks right to me. It came out the right answers, right? Yeah. So he had to do his order of operations. So actually, if you left the parentheses out, it would still do the correct order of operations. You guys see that? Because it will still do the multiplication first. So why did he put the parentheses in? For readability. Okay, so a lot of times, sometimes we'll put these parentheses in to make sure we got our equation right and for readability. So remember your order of operations. And then he has an else if gender equals M. Now what could he have done here? Would this work the same way if I got rid of this? And for his code, yes it would. Because he makes them stay here until it's an M or an F. So if it's not an F, it got to be an M. Now, if you didn't check for this, you would want to keep, oops, dang it. You would want to keep the else if in here, because if they typed in something else other than F or M, you wouldn't want to get into the else part. Okay, but know how you can tell that code will work the same way if we took that out. Okay. And so which way is more efficient? The less Boolean checks you have, the more efficient it would be. All right. And I know, we don't concentrate on efficiency in here, but if you are a computer science major, start thinking about efficiency and how you could always make your programs more efficient. That's one of the main things computer scientists do, is always trying to make their programs more efficient. Okay? All right. Well, anyways, so he has number of chocolates, and he has BMR divided by 230. Are we doing any int math here? No, because BMR was a double. Okay, so as long as he was a double, it's a double divided by an integer, and we'll get a double, and we won't have int math. Okay? And so then it outputs the number of chocolate bars, and that looks awesome. And actually, when did you use your start? You didn't use this guy. You were going to repeat it probably, right? Maybe? That's okay. That's okay. So Jeff likes to use go-to statements, which are not looked up upon in the programming world, but they do work sometimes, right? All right. So, good job. That looks beautiful. So A, check. So if your program looked mostly like this, great. Should we look at somebody else's? Are you guys okay with this? If you look at one other person's, we could look at it really fast just to see a difference in the programming problem. Should I just randomly pick somebody? Or who else wanted to share, actually? And see, your last name, tell me your last name. Oh, Dean? Oh, that's fine. That's cool, Dean. Okay, we can look at yours. And don't worry, we'll have lots of times to share, actually. So this was in the lab and homework on strings. Oh, it's McKenna. Okay. And I'm kind of bad with names, but I'm getting there. All right. If you tell me your birthday, I'm really good with birth dates. I'm a numbers person. I can remember your birthday. So we'll go over this one kind of fast, but just to see another way you can program it. Probably all of yours looks a little bit different. Okay. So note, she used a character for her gender, and that looks great. And then she has her input. Oh, and she has her introduction and then her input. I might get rid of these, though it's not detrimental that you get rid of those. Actually, it looked okay the other way, too. We just want it to be readable. But usually you group your input together. And then we have equal equals for the lowercase m and equal equals for the lowercase f. So same thing with you. If you're not doing error checking, you could have just had this in else. But it is good since you didn't do any type of error checking that you actually checked and not did some weird calculation. And then she did her calculations, and they look correct. And then she does her division, and that looks great too. And you output your BMR. Did you output your BMR? So probably output your BMR next time, but did it say to output your BMR? Or just the number of chocolate bars? I don't even remember. But you did calculate. It looks like it calculated right. And you probably outputted it at one point, hopefully, to see that it was the right calculation. So maybe output your BMR. And just because I don't want to open up another person's program, I'll just show it on here. You could have used the AND operator here, or not AND, OR operator. And it would be an OR, not an AND. And you could have checked for the uppercase letter as well. Now, you didn't have to. The program didn't tell you to. But if you wanted to check for both upper and lowercase, you would use the OR operator, because it could be lowercase m or uppercase m. And we know it's not the AND operator because it can't be both lowercase m and uppercase m. Okay. Sometimes we get confused which of these to use. But just always ask yourself, can it be both? No, it has to be separate. It has to be an or operator. Okay? And you could have done the same thing down here and checked for the uppercase F. So, perfect. But good program. Nice and neat. Has her name at the top. Good. So good. So if your program looked like that, yay. We're getting somewhere. All right. Cool. All right. So that was our homework for our strings. And this one we'll go over on Thursday. Now for your lab on strings. Now many people noticed that this chart I got had the wrong number of digits here. This was a chart I found online, and how many digits did our floating points have? 6. Okay. It was good that we noticed that. I need to fix that next time around. But note that some systems do use 7. That's where this chart came from a different, system that they were using, or a different compiler. All right. Any questions on these guys? It was kind of weird how, the 0.1s added up and they were the wrong values. Hopefully you found that odd. And remember, it's because, they have that little tiny conversion, error, because we can't convert 0.1 because it's an infinite number, so you can't store it in a computer. So it rounds it. And when you take those little tiny rounding errors and you add them up 10 times, you get a big error and you get the wrong answer. Okay. Now, did anyone realize why float variable actually gave you the right answer? That was kind of weird, right? So when we did float variable, it outputted the 1, and here it was 0.999, and here's 0.999. It's because the float variable truncated off a lot of that rounding error. And when it truncated off, that means it just chopped off a lot of the rounding error. You don't see that rounding error when you add them together. All right. Let's see here. And then any questions on our branching homework? I don't think anyone had questions on this guy. All right. Well, I don't want to go over this homework problem, and you got this homework problem, so I think I'll leave the rest of the class today for time for you guys to work on either your homework, or if you haven't finished this guy and he's due tomorrow, I would finish this programming problem, this loop right here. Okay, does that sound like a good plan? And then just read your textbook and study for Thursday's Jeopardy review. Okay? So I'll just leave the rest of our class time today to work on your homework or to ask me questions. And just be ready. Yeah, Thursday it'll be a full day because we'll go over this problem and then we'll do Jeopardy review. Any other questions though?